Hello everyone. Today we are going to discuss about Charles law. In the last class we have done Boyle's law. So in this Charles law, what it is talking about? So when you keep pressure constant, so the volume of the gas is directly proportional to temperature. What does it mean? When you keep the pressure is constant, the volume of the gas, as temperature is increasing, volume of the gas also increases. And if temperature is decreasing, volume of the gas also decreases. So what is the concept here? If you see, if a gas is enclosed inside a container, if a gas is enclosed inside a container having frictionless piston and it's having initial volume V1 and initial temperature is T1. As we told, it is directly proportional. So what we can say, let's take, we have increased the temperature. We have increased the temperature to T2. We have increased the temperature to T2. That means by providing heat. So when you provided heat and we have increased the temperature to T2, so what happens here? The gas molecules which are present inside this, so they are going to gain kinetic energy. So how they gain kinetic energy? We are going to study what is that? The kinetic energy of the gas molecules is directly proportional to temperature. That means if you increase the temperature, if you provide the heat, then what is going to happen? The gas molecules gains kinetic energy. Hope you're getting my point. So which is going to helpful in their random motion. So when they gain kinetic energy of the gas molecules gain kinetic energy, what is going to happen? They will strikes to the walls of the container with more force. Because of more energy, these gas molecules will strikes and the collides with the walls of the container with much more force. So due to the strong force of collision, what is going to happen? Their pressure is going to increases. Remember, their pressure is going to increases if you give more temperature to this. So when pressure increasing, so what we told here, we have to keep the pressure constant. Since we have to keep the pressure constant, so due to increase in temperature, pressure of the gas is increasing, but we have to make the pressure constant. So because of that reason, what we have to do, the volume of the gas has to be increased. When volume is increasing, so that initially how much of pressure was there, same amount of pressure is going to be maintained. How? Because as we know that pressure is inversely proportional to volume in what is it? Boyle's law we have understood. So in this case, as volume is increasing, pressure is going to fall and it will maintain the initial pressure how much it was there. Hope you clear. So as temperature is increasing, pressure increases. So to make the pressure constant, we have to increase the volume. So in this case, what is going to happen? As temperature is increased, so the volume of the gas molecules are going to increases because of more kinetic energy. Hope you clear this concept. And what is this statement is talking about? So in this statement, what it is saying, the volume of a given mass increases or decreases by what? 1 by 273 times of its initial volume. Okay, for every rise in 1 degree centigrade. That means if 1 degree centigrade is going to rise, when temperature is going to rise, how much of volume it is going to increases. So initial volume, let's take V0 was the initial volume. Then what is going to happen? If you increase, let's take at 0 degree centigrade, the volume is V0. And if you increase 1 degree centigrade of temperature, so how much of volume it is going to increase? So 1 by 273 times of its initial volume. If initial volume is V0, so how many times it is going to increases? V0 plus V0 by 273 times. It is going to increases its temperature. If the same amount of, if you decrease the temperature, definitely volume is also decreases. But how many times it is going to decreases? 1 by 273 times of its initial volume. It is going to be decreased. Let's see with the example here. Let's take at 0 degrees centigrades. Let's take at 0 degrees centigrades. The volume is V0. The volume is V0. Let's take at 1 degree centigrades, what is going to happen? At 1 degree centigrades, the volume becomes V0 plus, see, as I told you, for every rise in 1 degree centigrades, so how much of volume it is going to increases? Initial volume will be there. And how much it is going to increase as extra volume is going to increase because of increase in 1 degree centigrades, it is 1 by 273 times of its initial volume. That means initial volume was V0 And how much times it is going to increases? By 273 times. How much of degree increased? 0 to 1 degree. So it is what? 1 is going to be multiplied here. So this is the volume which is going to increase. If you let's take if increase in 5 degrees centigrades, if temperature is increased 5 degree. So how much of volume is going to increase as V0 plus. So what is that? V0 by initial by 273 into how many times? 5 times it is going to increases. Let's take if minus 10 degrees centigrades if it is increased. If temperature decrease to minus 10 degrees centigrade, so what is going to happen? V0 plus V0 by 273 into minus 10 into minus 10. If the temperature is increased to minus decrease to minus 273 degrees centigrades, so what is going to happen here? V0 plus V0 by 273 into minus 273. So 273, 273 cancelled. V0 minus V0. Now volume becomes how much? Volume becomes 0 at minus 273 degrees centigrades. This minus 273 degrees centigrades, what happens? The gas is going to have zero volume. This is called absolute temperature. This is called absolute temperature. Hope you are getting my point. So at this condition, what is going to happen? The temperature becomes, what is that? Volume becomes zero. And as well as in further laws also, we are going to understand this is minus 273 degrees centigrades, which is a hypothetical concept. But still at this temperature, what is going to happen? Volume becomes zero, pressure becomes zero, and kinetic energy of the molecules are going to be zero. What does it mean? The all molecular motions are going to be ceases to operate. So all molecular motions will become zero. Everything becomes zero at minus 273 degrees centigrades. So it is discovered by Kelvin. So that's why so 0 degree centigrades is called as my 273 kelvins. So he has taken 0 degree means 273 kelvins. So this temperature is called absolute temperature. Hope you are getting my point. Similarly, if you can write it for, let's take at T1 degree centigrades, the volume at T1 degree, I'm writing here, the volume at T1 degree centigrades. T1 degree centigrades. What is going to happen? Volume. So V1 becomes, what is that? V0 plus uh, it will become V0 by 273 273 into T1. Or similarly, if you take V0 common, so V1 is equals to V0 taken common. So 1 plus T1 by 273. So it can be solved by what is that? V0 into 273 plus T1 by 273. So this is for one gas. This is for one gas. So similarly, we can do it for V2 also. What we can write finally? V0 273. The temperature becomes how many degrees centigrades? T2 degrees centigrades by 273. So if you find out the ratio between V1 and V2, if you find out the ratio between V1 and V2, what we are going to get? So V1 by V2 is equals to what we can write here? V0 273 plus T1 by 273 divided by V0 273 plus T2 by 273. So V0 cancelled, 273 cancelled. So it is what? V1 by V2 is equals to 273 plus T1 degrees centigrades. T1 degrees centigrades by 273 plus T2 degrees centigrades. So we know that 273 plus temperature in degree centigrades, it will be called as what? Kelvin. So the temperature in Kelvin. So similarly 273 plus T2 means what is that? Temperature in Kelvin. So what we can write, it can be written as T1, capital T1 by capital T2. Finally what we got here? Finally V1 by V2 is equals to T1 by T2. And whenever we are solving the questions related to Charles law, in this gas laws especially, the temperature we have to keep in kelvins. Hope you remember for any kinds of calculations. So we have to keep the temperature in Kelvin. So this is all about the conceptual knowledge regarding Charles law. And next we are going to see the graphical representation, very much important. So if you see the graphical representation, so in the graphical representation, we can see the graph has to be drawn between volume and temperature. What is that? Volume and temperature. As we know that, before doing this graphical representation also, I want to tell you one concept. That is, here volume is directly proportional to temperature. In this case of Charles law, volume is directly proportional to absolute temperature. The absolute temperature, what is that? Minus 273 degrees centigrade. That means there is 0 kelvins. So in this case, so what we can write here, when you lift the proportional symbol, we have to multiply constant, that is k, and finally what we can write, v by k is, v by t is what? Constant k. Is it clear? So this is what the Charles laws mathematical point of view, and this is what very much important regarding for solving the numericals. And here in this graphical representation, as we know, the graph has to be drawn, what is that, between volume and temperature. When you draw the graph between volume and temperature, what kind of relationship it is having? It is having directly proportional relationship. When it is having directly proportional relationship, so what kind of curve? Again, we are going to get straight line curve. So whether it is going to be straight line, it has to origin from the, it has to start from the origin, or it has to start from the some y-axis. So that one we can understand by comparing it with y is equal to mx plus c, that is straight line equation. That is, we can compare v is equals to kt, it has to be compared with y is equals to mx plus c. As we know, y on y-axis, what is there? Volume. On y-axis, volume is there. On x-axis, what is there? Temperature is there. So m means what? Slope. M means slope, that is k. And what is y-intercept? Y-intercept is 0. That means the graph has to start from origin. Since the graph has to start from origin, so this is the curve. And all I forgot to mention, so the graphs which are done in the case of Boyle's law, that is between pressure and volume, the curves are called as, the straight lines or the curves are called as what? Isotherms, because we are keeping the temperature there constant. That's why they are called as isotherms. So in this case of Charles law, since we are keeping the pressure is constant, so the curves are called as, or the graphs are called as isobars. So this is what called isobar, because isobar means where the temperature is remaining constant. Isotherms means where temperature is remaining constant. In the case of isobars, where pressure is remaining constant. Is it clear? So this is what about isobars. So the graph is drawn between volume and temperature. If let's take two or more at different pressures, if you are doing, so the graph, so what is going to happen? You have to draw like straight lines like this at different pressures, P1, P2, P3, like this pressures. And we have to understand which pressure is more. Which pressure is more? Here, which pressure is more? How will you identify? Again, the same thing. We have to compare it with ideal gas equation. That is, PV is equals to nRT. So we have to get V by T. So V by T is equals to nR by P. So V by T means what is that? K. That is what K means. It is slope. K means what is that? Slope. So K is equals to nR by P. So from this what we understood, K is inversely proportional to P. Means slope is inversely proportional to P, means larger the pressure, lesser will be the slope. Remember, larger the slope, lesser will be the pressure. Higher the pressure, lesser will be the slope. So from this point, what we have understood here, so more is the, this slope is higher slope. So higher the slope, its pressure is less. This is the lower is the slope, it will be the higher pressure. So this is very much important. P3 greater than P2 greater than P1. So this was very much important regarding uh, the concept related to gas laws, especially in the Charles law. And next, what we are going to understand is the concept of absolute temperature, how to identify absolute temperature in the graph. Okay, so when you see, when this pressure volume is equals to K into T. So when you're doing this, volume is equals to K into T. T means what? Generally, we are writing it in degree centigrades. If you mention, it isn't writing in temperature, especially in the form of kelvins we have mentioned. If you mention in the degree centigrades, like we have to convert into what is that? 273, 273 plus temperature in degree centigrades. Hope you're getting my point. Temperature in degree centigrades. So now what is going to happen if you multiply V is equals to 2, what we can write? Uh, KT plus 273K. So it has to be equated with what? Straight line equation. So this is what y is equals to mx plus c. That means on y-axis v, on x-axis what is that? Temperature. So this is what y-intercept. So this time there is y-intercept. So the graph is not going to start from the origin. So it is going to start from some point on the y-axis, some point on the y-axis. So what you have to do? We have to draw a graph like this, and it is what? Temperature in degree centigrades, and this is what? Volume. So now the graph is, since we have equated it with straight line, so it is going to have straight line graph, but it is not going to start from origin, because in this case the y-intercept is 0. That's why the graph started from the origin. But here there is some value of y-intercept. What you're going to start, the graph has to start from certain point on the y-axis. So the straight line, the graph will be straight line, no doubt. It will start from certain point on the y-axis, because this is what? 273k. This 273k is what? Y-intercept. And when you extend this straight line graph towards backward, what is going to happen? This is the point which you are getting on the x-axis that shows the value of temperature. What is the temperature here? This temperature is called minus 273 degrees centigrades. So this minus 273 degrees centigrades is called as what? Absolute temperature, where as you are seeing here, what is the volume? See, the point on the x-axis means y-axis will be 0. Y-axis means what is that? Volume. So in this case, volume is 0. So this temperature is called as what? We discussed absolute temperature. Hope all of you clear what is this Charles law. Charles law means when the temperature, when the pressure is remaining constant, the volume of the gas is directly proportional to temperature. That means if you, in what respect the volume is going to increase, in the same respect temperature is going to increase. That means, and vice versa. So as temperature increasing, volume increases, temperature decreases, volume decreases. So this is what the concept, and we have understood the concept, we have understood the how the volume is increasing, in which times, or in how many times the volume is increasing with respect to temperature. We have seen the concept, and we have got the mathematical formulation. This is very much important, and also we have done graphical representation. So this is what all about Charles law, and we are going to practice. This is what conceptual video, and next we are going to do how to solve the questions related to Boyle's law and Charles law and all the gas laws and any topic I'm putting. So simultaneously, I'm going to provide another video of what is that? Solving the questions, especially which involves previous year questions, as well as we're going to see practice questions. Thank you.